horizontal, but y equals 0. That's good. These are fine. Good problems that we just looked at. But as I mentioned, no graph with the slant asymptote. Okay, this concludes the graphing for now. And the last section of this chapter is 3.6. And which page am I on? I'm on page 6. So this is 3.6, polynomial and rational inequalities. Okay, what is a polynomial and rational inequality? They're two different things, of course. Here's one. Negative x, x plus 1, x minus 3, less than or equal to 0. This is I'm sorry, I forgot to stop sharing. Sorry about that. Sorry. So 3.6, the last section of chapter 3, polynomial and rational inequalities. So what is a polynomial inequality? This one. Sorry about that. So this is a polynomial inequality of degree 3, as you see, x times x times x. So this is polynomial. How will a rational inequality look like? Here it is. These are examples. How do I solve something like this? If it's not factored, I have to factor it. So I gave two examples, one of each, polynomial, and the other one rational, in which part of the work was already done. I don't have to factor. I chose simple examples that are already factored. Okay, let's see how we solve the first one. So first question that I have for you, x could be 0. Maybe I should just write first the equation so you know why I'm coming up with these solutions. So if I had this equation, then I would obtain x equals 0. I would obtain x equals negative 1. And I will get another solution, which is x equals 3. These are important because I'm going to use a table to solve this inequality. The first row is values of x. Anything can go in there. The next row is the first factor. The next row is the next factor. The next row, of course, is the next factor. And finally, negative x, x plus 1, x minus 3. The whole thing. Because this is really what I need. I need the whole thing and then see when it's less than 0. Okay. I already have the solutions, the zeros of each factor. I will put them correctly in ascending order. Of course, I have to start with negative 1. I will continue with 0, and I will continue with 3. They're in ascending order. Negative x, well, it's 0 at 0. X plus 1 is 0 at negative 1. And x minus 3 is 0 at 3. Now for all these, like we just did with the slant asymptote, I will have to study the sign. What does that mean? Well, negative x looks like this. So it's coming from positive, going to negative, and crossing at 0. Okay. But the other two look like this. They're coming from negative and going to positive. Okay, fine. This is a product. If one of the factors is 0, the product is 0. Now, if the first one is positive, the second one is negative, and the third one is negative, what is the sign of the outcome? This times this times this. What will be the sign?
Positive.
Excellent. If the first one is positive, the second one is positive, and the third one is negative, what will be the sign of the
Negative.
yes? First is negative, second is positive, last is negative. What will be the sign?
Positive.
Very good. Finally, the first is negative and the other two are positive. What is going to be the sign?
Negative.
That's it. Only now I ask myself, what am I after? Which sign is less than or equal to 0? Well, the answer is negative. So I'm looking for negative sign. Okay, looking for negative, looking for negative. I found it. Looking for negative, looking for negative. I found it. So this is less than or equal to 0 only when I pick x between -1 and 0, and when I pick x between 3 and infinity. This is the solution. What is the solution? -1 comma 0 with a bracket in both because of the equal symbol, union, bracket at 3, comma, infinity, of course, with parentheses. This is it. That's the entire section. That's all we need to do to solve polynomial and rational inequalities. I let you choose polynomial, rational, anything you want. They are on page 443. Anything you like to pick. From 17, including rationals, which we're going to look at anyway, 60. Anything you want from 17 till 60. As many as you want, anything you want. Yes, some of them are not factored. So of course we need a little bit of work to factor them first. Please choose or I will.
Can we do 20?
Yes, let's start with 20. Very good. Where are you? 20. I see it. So we have x squared plus 2x less than 0. Perfect. We need to factor. So this is 20 on 443. Can anyone factor this for us? It has to be a product. Otherwise, I cannot use the table. I have to have a product or a ratio on one side and definitely 0 on the other. So I have to work on this a little bit. How do I factor this? Anyone, please? The greatest common factor. We've done that. Descending order, greatest common factor, la 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 la.
X.
Yes. And what is left in parentheses?
X plus 2.
That's it. We're done. Table. X is the variable in the problem. X is the first factor. X plus 2 is the second factor. And what I'm really interested in is in the product. Negative infinity to infinity. When is this 0? When x is?
0.
Of course. When is this 0?
At -2.
Very good. Careful, they have to be in ascending order. Negative infinity, -2, 0, and infinity. Good. So this is 0 at 0. This is 0 at -2. This is 0 when either one is 0. What is the sign of these two? This or this?
The first option.
Yes. I'm multiplying two negatives.
I'll get a positive,
I'm multiplying a positive and a negative.
negative,
I'm multiplying two positives.
be positive.
Good. Only now, I think, what am I asked to determine? Okay, I'm asked to determine this because only negative is less than 0. I'm looking for negative. Ah, I found it. So the solution is without equal symbol, parentheses, -2, 0. Because this looks like an ordered pair, I always like to put in front x in the interval. -2, 0. So it's not considered -2, 0. -2x is x and 0 is y. No, this is an interval just for x. That's it. Okay, let's choose. Maybe we should. Yes.
30,
Which one?
34.
34. Very good. Let's continue with 34. This is like a puzzle. Yes, there are other methods. 5 minus x everything squared and x minus 13 halves less than 0. Perfect. Good. X is the variable in the problem. 5 minus x squared, I'm going to use it as is. 5 minus x everything squared. And x minus 13 halves. And what I'm really interested is in the product. So 5 minus x squared, x minus 13 halves. Good. Which x makes this 0? Very good. So 5 is one of them for now. Which x makes this 0? The same thing, 13 halves, right? Now I have to be careful because 13 halves is 6.5 and this is 5. So I have to put 5 first and then 13 halves follow. Careful. This is 0, this is 0, this is 0, this is 0. Because if either factor is 0, the product will be 0. Let's start with the second one. X minus 13 halves. Is it this or is it this? Does it have a, yes, positive leading coefficient? In other words, positive slope. Good. So it's this. Now, because of the power 2, no matter what I plug in, this will always be a positive number because it's squared. If you plug in 6, 5 minus 6 is -1, -1 squared is positive. If you plug in 10, 5 minus 10 is -5, squared is 25. If you plug in 0, 0 minus x, I'm sorry, 5 minus 0 is 5, 5 squared is 25. No matter what, except when x is 5. Otherwise, it's always positive. Good. So now, I multiply a positive by a negative.
Negative.
Good. I multiply a positive by a negative. And I multiply two positives. So now, we have to be very careful here because there is no equal symbol, right? So we are still looking for negative, but not 0. So I'm looking for negative. I found negative, which is this, but I have to exclude 5 because at 5 is 0 and 0 is not here. So the solution has to be x in the interval -∞ 5 union 5 13 halves. I cannot include this because of I don't have the equal symbol. I can only choose plain and simple negative. Negative, negative, but not 5. Very nice pick. Very good pick. It was an interesting question. Any questions? Okay, let's pick another. This is the end of chapter 3. So let's pick another, and maybe we want to pick from rationals now. And then we go back to other polynomials. Let's look at a rational because we haven't looked at any. Okay, I'll pick the first rational. I'm going to pick 49. And then you pick the next. 4 minus 2x divided by 3x plus 4. It's less than or equal to 0. Not a difficult one. I don't have to factor anything. It's already factored for me. This is one factor. This is one factor. X is the variable in the problem. Always put correctly in descending order everything. Negative 2x plus 4 and 3x plus 4. And of course the ratio. Negative 2x plus 4, 3x plus 4, and x can be anything. I need to determine when this is 0. Negative 2x plus 4 is 0. X equals negative 4 over negative 2. And this one, 3x equals negative 4. X equals negative 4/3. These are very important numbers. I need to obtain them before I put anything in the table, and they have to be in the correct ascending order. First, negative 4/3, and then I plug in 2. What happens to this fraction when x is negative 4/3? When x is negative 4/3, the fraction is anyone, please? I know you know. So what is the fraction when x is negative 4/3? Please? What happens to the fraction when x is negative 4/3?
0.
Careful. I didn't say when x is 2. When x is 2, the fraction is 0. But when x is negative 4/3, the fraction is how much? You told me this tonight on a different function. We said when the numerator is 0, the fraction is 0, and when the denominator is 0, the fraction is
Undefined.
yes. Yes, yes, yes. Yes. Actually, I don't need to do the whole thing, just the fraction. So sorry, I didn't mean to. There is no need to write, just the fraction. Good. Because the other ones are not undefined. Just the fraction is undefined. Okay, perfect. So we know that this is 0 at 2. We know that this is 0 here. I cannot write it just yet because it's not dry yet. And let's study the sign. Careful, the leading coefficient is negative. What will be the sign for the first one? This or this?
Second option.
The second option, because it has a negative leading coefficient. So it's coming from positive infinity going to negative infinity. Good. So this is 0 here. Still too wet to do anything for me. Okay. So this is a positive leading coefficient. So positive leading coefficient means it's coming from negative infinity going to positive infinity. That's why the fraction is undefined. When we divide a positive by a negative, the outcome is negative. When we divide two positives, when we divide two positives, and when we divide a negative by a positive. Again, it happens that we chose all of those looking for negative. Is the fraction ever negative? Yes. Here and here. The equal symbol is there, but I cannot choose negative 4/3 because it's undefined. But I have to choose 2. So negative infinity to negative 4/3 with parentheses because it's undefined, but union 2 is included because it's 0, that's okay. So x is in this interval. And this is finally 0. So the only difference between rational inequalities and polynomial inequalities is that these rational expressions may be undefined.